Hey everybody, it's the Jazz Architect. Today we're talking about a simple but slippery question. Is artificial intelligence a machine? Is it software? Is it a combination of both, or is it something else entirely? This week, I read a fascinating book called The Coming Wave by Mustafa Suleyman, written by Michael Basher. The book encouraged me to step back and ask a basic but important question. What exactly are we talking about when we say artificial intelligence? Many people picture artificial intelligence as a robot, a metal machine, or even some strange alien voice speaking in a language they do not understand. But that's not really what AI is. Artificial intelligence is created by human beings. It involves software, data, mathematics, and computer hardware, working together to recognize patterns, generate responses, make predictions, and perform certain tasks. I also realized this week that simply knowing what the acronym LLM stands for, which is Large Language Model, does not necessarily tell us what an LLM actually is or how it works. I asked several people to explain an LLM to me, and you might be surprised by the range of answers I received. Almost everyone described it differently, especially musicians. The confusion helped me inspire this episode. I want to clarify what an LLM is, how it functions, what it needs in order to work, where it exists, and how it differs from the apps and services we use every day. Throughout this episode, I want to answer 5 basic questions. First, what is the difference between hardware, software, artificial intelligence, and a large language model? Second, where does an LLM actually live? Third, how is ChatGPT different from the underlying model and that powers it? Fourth, why can there be different models and specialized AI assist for particular professions and industries? And finally, why should we not think of an LLM as a human brain? By answering these questions one at a time, I hope we can remove some of the mystery surrounding AI and build a clearer picture of what this technology is, how it works, and how humans fit into this whole process. So let's get down to it. Let's go, guys. What's the difference between hardware, software, AI, and the LLM? These 4 terms are connected, but they do not mean the same thing. Hardware is a physical piece of equipment. It includes things like your phone, laptop, computer chips, processors, and the powerful servers inside data centers. Hardware is the part you can physically touch. Software is the collection of instructions and programs that runs on the hardware. Your email, the app, internet browser, and music recording programs. They're all examples of software. Artificial intelligence is a broad category of computer systems designed to perform tasks that we often associate with human abilities. Those tasks may include recognizing patterns, understanding language, identifying images, making predictions, or generating new material. An LLM is one particular type of artificial intelligence. Its specialty is language. Let me repeat that, language. Because I like to eat, let's use a kitchen as an example. The kitchen itself, the stove, the refrigerator, oven, knives, pots, and pans, this is the hardware. Okay, now you come in with a recipe. The recipe and the operating instructions are like the software. Now we're on to the artificial intelligence part. Pay attention. The artificial intelligence is a capability within the system that can examine information, recognize patterns, and generate a response instead of following only one rigid sequence every time. Okay, so that's like a highly developed thought process, the artificial intelligence, AI. Last is the LLM. It's the language specialist. It works with words, sentences, questions, summaries, translates, and conversations. The LLM cannot do its job without the hardware and software surrounding it. All these parts work together. So, what exactly is an LLM? An LLM is a type of AI software trained to recognize and generate patterns in human language. So, you got to know the language and it recognizes patterns. That's what an LLM, large language model, that's what it is. It learns by processing enormous amounts of written material and examining relationships among words, phrases, ideas, and writing styles. It does not work mainly like a library retrieving one stored sentence at a time. Instead, it develops a vast mathematical representation of how language tends to work. When you ask an LLM a question, it creates its response by predicting one small piece at a time. Which word or part of a word is likely to come next, based on your request and the patterns it learned during training. Here's a musical analogy. Imagine a jazz musician who's listened to millions of songs, studied countless solos, and learned the patterns of harmony, rhythm, melody, and a musical style. When the musician improvises, the musician is not simply repeating one memorized solo. The musician creates something in the moment by drawing from patterns absorbed over many years. An LLM works in a somewhat similar fashion, but with language instead of music. Your prompt is like calling the tune, setting the tempo, and naming the key. The LLM responds by improvising with words. But the analogy has an important limit. A human musician has personal experiences, emotions, intentions, memories, and an understanding of the performance. An LLM does not experience the meaning of its words the way a human being does. It may be extremely skilled at producing language, but it can still generate information that sounds convincing and is incorrect. We can also return to the food analogy. Imagine a chef who has studied thousands of recipes. You tell the chef, excuse me, chef, could you make me something that's light and spicy? And the chef uses learned patterns to create a meal that fits your request. An LLM does something that's very similar actually with words. You give it instructions, and it arranges language based on patterns it has learned. But the LLM cannot taste the meal. It does not become hungry, enjoy the food, or understand the experience of eating. It may produce a recipe, but a human being still needs to decide whether that recipe is accurate, useful, safe, and appropriate. So an LLM is not a robot, a human brain, or a machine that thinks exactly as we do. It is a powerful language pattern system created by people, running a software on computer hardware, and guided by questions and instructions humans give it. Now that we understand those basic differences, let's move on to the second question. Where does an LLM actually live? Most of the time, a large LLM does not live entirely inside your phone or laptop. It runs on powerful computers called servers, usually located in large data centers. When you open an AI app and type or speak a question, your device usually sends the requests through the internet to the servers where the model is operating. The LLM processes your requests, generates a response, and sends the answer back to your screen. Think about ordering food through a restaurant app. Yeah, I like food. Your phone is where you place the order, but the meal is not prepared inside your phone. The order travels to the restaurant, the kitchen prepares it, and the finished meal is delivered to you. In the same way, your phone or computer is often where you communicate with the LLM, while much of the processing happens somewhere else. Some smaller models can run directly on a personal computer, phone, or company-owned server. This can be useful when privacy, speed, or working without an internet connection is important. But the largest models generally require far more computing power than an ordinary personal device can provide. So an LLM does not live in one magical location. It exists as software operating on physical computer hardware. That hardware may be in a distant data center inside a company, or sometimes right on the device in your hand. Now that we know where an LLM can operate, let's move on to the third question. How is ChatGPT different from the model underneath it? ChatGPT is the product, the app, website, voice experience, and conversational interface that allows you to communicate with artificial intelligence. The underlying model is the language processing engine that receives your words, recognizes patterns, and generates a response. Think of a restaurant. The underlying LLM is like the chef working in the kitchen. The chef has learned techniques and ways of combining ingredients. ChatGPT is more like the entire restaurant experience. The menu, the server who takes your order, the dining room, and the system that delivers the finished meal. You interact with the restaurant, but much of the work takes place behind the scenes. ChatGPT may also provide features beyond the basic language model, such as voice conversations, file analysis, image capabilities, web access, memory, and connections to other tools. The model remains central, but it operates as one part of a larger system. So when you use ChatGPT, you are not interacting with an isolated LLM by itself. You are using a complete product that connects your request with a model, additional instructions, tools, and safety system. This brings us to another common question. Do ChatGPT, Gemini, Llama, and other AI products all use the same LLM? The answer is no. Different companies create different model families. ChatGPT is an open AI product powered by models from OpenAI's GPT family. Gemini is the name Google uses for its family of AI models and for its public-facing AI assistant. Llama is Meta's family of models, which developers and organizations can use to build their own AI products. A simple way to picture this is to think about cars. The AI assistant is like the entire car. The underlying model is like the engine. Different companies build different engines, and those engines may have different strengths, limitations, and purposes. Some AI products can even use more than one model, choosing one for writing, another for coding, and another for analyzing images or documents. The naming can be confusing. ChatGPT is primarily the name of the product, while GPT refers to the model family underneath it. Google uses Gemini for both its models and its assistant. Llama is mainly the name of Meta's model family rather than one universal chatbot. So when we say an LLM, we are talking about a category of technology, not one single model shared by every company. That leads naturally to our fourth question. Why can there be specialized AI assistants? I was surprised to learn that you can go into AI. AI has a marketplace and find specialized assistants designed for particular fields, professions, and tasks. I heard more about this while watching an INSEAD program called Co-Intelligence, Living and Working with AI, featuring Ethan Mollick. For example, you might find an assistant focused on education, construction, law, business, music, healthcare, or another field. Some of these assistants may have access to carefully selected documents, detailed instructions, databases, or tools related to that subject. It is important to understand that many of these are not completely new LLMs, but from the ground up. They are often specialized assistants built on top of a larger general purpose model. Think of a doctor who receives broad medical training and later specializes in cardiology or surgery. The doctor still has a general foundation, but additional knowledge and experience create a particular area of focus. A specialized AI assistant works in a similar fashion. It may use a broad model underneath while receiving extra instructions, information, tools, or training related to one's field. This could save people a tremendous amount of time. Instead of beginning every conversation from scratch, you may be able to start with an assistant that already understands some of the vocabulary, common questions, documents, and working practices of your profession. But specialization does not guarantee accuracy. A legal assistant is not automatically a lawyer. A medical assistant is not automatically a physician. A music assistant is not automatically an experienced musician. Human expertise, fact-checking, professional standards, and judgment are still necessary. And now we come to our fifth and final question. Perhaps the most important and most debated question of the episode. Why should we not think of an LLM as a human brain? This is where the general public becomes deeply involved, because people naturally form opinions based on what they can see and hear. When an LLM can speak, write, answer questions, tell jokes even, and explain complicated ideas, it is easy to conclude that it must be thinking and understanding exactly as a person does. Some people become fascinated. Others become terrified. But what something appears to be doing is not always the same as how it actually works. Imagine a highly advanced flight simulator. It can recreate the sounds, movements, controls, and visual experience of flying a plane. It may look and feel remarkably realistic, but the simulator is not actually 35,000 feet in the air. In a similar way, an LLM can produce a remarkably convincing simulation of human conversation, but it does not have a biological brain, a body, a childhood, personal life experiences, emotions, or human awareness. It processes mathematical patterns and generates language one piece at a time. It can produce a thoughtful sounding response without experiencing the meaning of that response as a human being. That's pretty crazy, isn't it? But it is a machine. This does not mean that people's concerns should be dismissed. Some concerns about AI are reasonable and important. AI can make mistakes, repeat biases, spread false information, affect employment, and be misused. But fear can also grow when people do not understand what the technology is actually doing. Humans often fill gaps of knowledge with imagination. Just think how often you make up stuff when you really don't know the answer. And when a machine speaks in a convincing human voice, our imaginations can move very quickly. This reaction to new technology is not unusual. Throughout history, major inventions have created excitement, confusion, fear, opportunity, and disruption. In the coming wave, Mustafa examines the history and explains how powerful technologies can create enormous benefits while also introducing serious risk. The important question is not simply whether technology is good or bad. The challenge is learning how to understand it, guide it, establish safeguards, and maintain human responsibility over how it is used. So when we discuss LLMs, we should neither treat them as magical human brains nor dismiss the legitimate concerns surrounding them. We need accurate information, thoughtful judgment, responsible leadership, and an informed public conversation. All right, guys, that brings us to a close of another episode. Today, we separated hardware from software, AI from LLM, and an AI product from the model operating underneath it. We explored LLMs, why different companies create different model families, how specialized assistants are developed, and why producing human-like language is not the same thing as possessing a human mind. The more clearly we understand these distinctions, the better prepared we will be to use AI thoughtfully and to make decisions based on knowledge rather than fear or hype. Okay, once again, keep your eyes and ears open, stay kind, be a groovy person, and as the jazz architect always says, being creative and innovative is the best way to start and end your day. See you soon.